For the second section, we have 4 students, just 4 students. So the first presentation will be Dương Lập Khang and Quỳnh Anh. Yeah, sorry. Rồi cô quá thì còn chưa? Cô ấy
Dạ
bắt
chưa
đầu.
thầy, bây giờ mới làm nè thầy.
Rồi.
Mày có thể ngồi đây nhưng mà thầy ơi, chuyển coi tắt chuông điện thoại đi.
Rồi, xin chào một lần nữa các thầy cô và các bạn. Xin chào tất cả các thầy cô và các bạn. Chúng ta sẽ bắt đầu cái buổi bảo vệ của chúng ta với lớp HC17 thực phẩm. Hôm nay hội đồng chúng ta gồm có tất cả là 4 bạn. Đầu tiên thì xin mời hai bạn là Dương Lập Khang và Nguyễn Ngọc Quỳnh Anh.
Đóng cửa phòng mày ơi.
Đề tài các bạn là hoạt tính kháng oxy hóa và tính chất chức năng dịch thủy phân từ phụ phẩm cho thác lát. Xin mời hai bạn share màn hình và chúng ta bắt đầu.
Dạ vâng ạ.
Can you see my screen yet?
Hai bạn này là có nguyện vọng bảo vệ bằng tiếng Anh đúng không?
Dạ đúng rồi.
Okay. So, Miss Yên, so will you stay with us up to the end? Miss Yên, yes or no? Please turn your microphone on and confirm, please.
Yeah, yes, I will.
Okay. Thank you. Thank you. Okay. Okay. Okay, Khang and Quỳnh Anh, please show your slides, and you can start your presentation.
Okay, so
you can see our slide, right?
No.
Our slide.
Wait.
Not yet.
Chiếu lại đi Khang.
You can see it right now, right? Can you see it? Can you see the screen?
Now we see it.
Yeah.
So please.
Welcome council to our bachelor's thesis defense. Our team, including Dương Lập Khang and me, Nguyễn Ngọc Quỳnh Anh, mentored by Ms. Võ Đình Lệ Tâm, will present our topic, antioxidant activity and functional properties of protein hydrolysis derived from clown feather bed byproducts. The thesis consists of 4 parts: introduction, materials and methods, results and conclusion.
Let's start with the introduction. First of all, I would like to explain why is it necessary to carry out this topic. Our candidate was clown featherback as depicted on the screen. Its meat is full of nutrition and is currently processed to produce fish cakes and fish balls. In 2014, the farming area and the production yield of the clown featherback were collected in Vietnam. As can be seen, the figures were significant. However, there is a concern in the production processes, which is economic inefficiency, since greater than 60% of the fish is being discarded throughout the manufacturing. Because of that, we decided to utilize the byproducts by using enzymatic treatment to produce antioxidative protein hydrolysis. The hydrolysis can be done in 3 ways: by chemicals, microbial fermentation, or by enzymes. By far, enzymatic hydrolysis has been considered the most beneficial method, and in our thesis, alkylase was used. So, an antioxidative peptide is a substance that can inhibit the initiation or propagation of harmful oxidative reactions, especially radical reactions. And the harmful effects of radicals have been known to associated with various types of cancer and other severe disease. And the application of enzymes in researching the protein hydrolysis with antioxidant activity have been widely studied, and some of the studies on fish skins are shown in the table. And in our thesis, 2 distinct assays were used to analyze the antioxidant activity, namely DBPH and ABTS scavenging assays. Further, the functional properties of the protein hydrolysis were also investigated. The 2 properties were emulsifying and forming capacity. The influencing factors affecting the functional properties can be divided into two groups: the nature of the peptide and the environmental factors. And in our thesis, the effect of pH values were tested.
Next,
Next,
we will
we
talk
will
about
talk
the
about the
materials and
materials and
methods
methods
applied for the
applied for the
study.
study.
For raw
For raw
material,
material,
the
the
skins of
skins of
Chitala
Chitala
annata
annata
taken from
taken from
processing
processing
plants were
plants were
ground and
ground and
kept in
kept in
freezing
freezing
condition at
condition
lab
at lab
B10.
B10.
Then we
Then we
proceeded
proceeded
the
the
research
research
following
following
this
this
procedure.
procedure.
After
After
the
the
skin
skin
treatment,
treatment,
the
the
chemical
chemical
composition
composition
was
was
analyzed
analyzed
as
as
moisture,
moisture,
crude
crude
lipid,
lipid,
crude
crude
protein, and
protein, and
total ash
total ash
content.
content.
Then we
Then we
determine the
determine the
hydrolysis
hydrolysis
condition
condition
via
via
substrate to
substrate to
water
water
ratio,
ratio,
enzyme to
enzyme to
substrate
substrate
ratio, and
ratio, and
hydrolysis
hydrolysis
time by
time
two
by two
methods,
methods,
DPPH and
DPPH and
ABTS
ABTS scavenging
to
to
obtain the
obtain the
hydrolyset with
hydrolyset with
highest
highest
antioxidant
antioxidant
activity.
activity.
The
The
hydrolyset was
hydrolyset
then
was then
analyzed
analyzed
for
for
amino
amino
acid
acid
composition,
composition,
pH
pH
value,
value,
and two
and two
functional
functional
properties
properties
as
as
farming and
farming and
emulsifying.
emulsifying.
The
The
selected
selected
enzyme
enzyme
for
for
hydrolysis was
hydrolysis was
acrylase
acrylase
from
from
Bacillus
Bacillus
licheniformis.
licheniformis.
Optimum
Optimum
condition for
condition for
using
using
acrylase
acrylase
was
was
pH
pH
7.5 and
7.5 and
55
55
Celsius
Celsius
degree.
degree.
In part
In part
3,
3,
we
we
perform
perform
results of
results
the
of the
research.
research.
First of
First
all,
of all,
the
the
chemical
chemical
composition
composition
of the
of the
material was
material was
investigated.
investigated,
With
with
25% of
25% of
crude
crude
protein on the
protein on
weight
the weight
basis,
basis,
in
in
comparison with
comparison with
16 to
16 to
43% of
43% of
protein of
protein
fish
of fish
skin,
skin.
Chitala
Chitala
annata could be
annata could be
considered
considered
as
as
a
a
potential
potential
source of
source of
protein for
protein for
bioactive
bioactive
peptide
peptide
production.
production.
Secondly,
Secondly,
for
for
hydrolysis
hydrolysis
condition,
condition,
the
the
scavenging
scavenging
activity of
activity of
samples with
samples with
SW
SW
ratio
ratio
ranging from
ranging from
1:1 to
1:1 to
110 was
110 was
shown.
shown.
Other
Other
parameters were
parameters were
fixed at
fixed at
pH
pH
7.5,
7.5,
55
55
Celsius
Celsius
degree,
degree,
ES
ES
40
40
unit per
unit
gram
per gram
protein, and
protein, and
hydrolyzed in
hydrolyzed
4
in 4
hours.
hours.
The peak
The
for
peak
both
for both
antioxidant
antioxidant
assays
assays
was
was
1,
1,
2,
2,
and we
and
use
we use
this
this
result for the
result for
following
following
experiments.
experiments.
For
For
ES
ES
ratio,
ratio,
we
we
experimented with
experimented with
sample
sample
from
from
20 to
20 to
100 U
100
per
U per
gram
gram
for
for
DPPH
DPPH
and
and
20 to
20 to
80 U
80
per
U per
gram for
gram for
ABTS
ABTS
assay.
assay.
The
The
graphs here
graphs here
indicate that
indicate that
the
the
highest
highest
DPPH
DPPH
capacity
capacity
was
was
fixed at
fixed at
80
80
ratio,
ratio, which
which distinguished from
distinguished
that
from
of
that of
ABTS
ABTS
at 60
at
U
60
per
U per
gram peak.
gram peak.
Therefore, we
Therefore, we
use the
use the
ratios at
ratios at
each
each
assay's peak
assay's
to
peak
test
to
the
test the
hydrolysis
hydrolysis
time.
time.
Uh,
Uh,
with
with
SW12,
SW12
hydrolysis
hydrolysis
time
time
ranging from
ranging
3
from
to
3
7
to 7
hours.
hours.
For
For
DPPH,
DPPH,
the
the
best
best
activity was
activity was
conducted at
conducted at
5-hour
5-hour
point,
point,
and for
and for
ABTS,
ABTS,
the
the
activity was
activity
peaked
was
at
peaked
6
at 6
hours.
hours. In
In total,
total,
we
we
collected two
collected two
condition
condition
sets
sets
for
for
each
each
method.
method.
The
The
following,
following, the
condition for
condition
best
for best
DPPH
DPPH
scavenging
scavenging
activity was
activity was
chosen in the
chosen in
next
the
step.
next steps. As a result,
The
the
hydrolyset
hydrolyset
obtained
obtained
present
present
IC
IC
values
values
for
for
DPPH at
DPPH
3
at 3
milligrams per
milligrams per
milliliter,
milliliter,
and
and
for the
for the
ABTS at
ABTS at
1.82
1.82
milligrams
milligrams
per
per
milliliter
milliliter
protein,
protein,
and reached
and reached 32.25%
32.25% of
of
hydrolysis
hydrolysis
degree.
degree.
Then, the amino acid profile of the final protein hydrolysis was determined. The green ones are essential amino acids, which accounted for 74% of the total, and the hydrolysis can be considered nutritionally valuable. As can be seen, some of the residues contributing to the antioxidant activity comprise noticeable proportions of the entirety. Among them, tyrosine was reported to cause antioxidant capacity. Other branch residues such as phenylalanine, valine, alanine can improve the antioxidant activity by enhancing the oil solubility of the peptides. Histidine, even though existed in low concentration, was also reported to exhibit antioxidation. Next, the emulsifying properties of the hydrolysate were determined. And the peak values for emulsifying activity and emotion stability were 15 meters square per gram and 15% respectively. Compared to the sodium CaCNH solution, the emulsifying properties were slightly poorer except for pH 4 and 5, and the hydrolysate can be considered as an emulsion booster to some extent. The forming properties fluctuated along with the changes in pH. The highest forming capacity the highest forming capacity observed at pH 3 was 1.1 times lower than that of albumin, while at pH 4 the hydrolysate exhibit the highest form stability and only 1.2 times lower than that of albumin. However, at other pH values, the property was significantly lower than compared to albumin, since the peptide length is not adequate for stabilizing a dispersed system, indicating the poor applicability of the hydrolysate as a forming agent.
In part 4, we have made conclusions for this thesis. The study suggested that glycolate-wasted skin could be considered as a natural source of antioxidant peptide supply for health benefits, and its functional properties can also be considered for further applications. We suggest some future researches such as optimization of hydrolysis condition, fractionation, peptide identification, antioxidant activity in vivo, and other functional properties. And finally, we expect that our product can be applied as peptide supplements for functional foods and pharmaceuticals. Thank you, Council, for listening.
Okay, thank you. So it's now the time for you to answer the question of the reviewers. So Miss I, please show the questions of the reviewers for both students. So Wunan, please, 3 questions, and Khang, 3 questions.
Yes.
Question 1. Additional nitrogen, for the fish sample is observed during the preservation. Is that correct? Yes or no?
As what I understand here, like for our product, then we have the hydrolysate. We aim to apply it to the food system as a preservation, because this is a possible thing, because like we have found out that our hydrolysate have the antioxidant activity, and
No. Try to answer the question. The question is the nitrogen addition, is observed during the preservation of your sample. Is that correct? Yes or no?
Well, I think this is the possible.
The question is not so clear, but as I understand, the nitrogen contents of your sample can be increased during the preservation, as I understand. Yes or no?
Well, if during the preservation of the product, then the nitrogen increase. You
Is
mean
that correct?
in our product? Nitrogen? I don't think so, because we don't have any new source to supply the nitrogen in our product. Just only the hydrolysate. Because during the preservation, then because our product including peptides and amino acids, so maybe somehow if
Your product, not your product, your material. That means your fish sample.
the fish.
Okay.
Uh,
So
well, then also I don't think it's gonna increase the nitrogen
Why?
of the fish because the protein of the fish during the preservation can only happen the process of denitроgenation.
Sorry, Guinan. I think the question is if some people add urea in the material or another sources of nitrogen to preserve the material, then you collect the material, and does that affect your results or your research?
Okay, I can. Okay, so this is the preservation from the processing plant where they release the skin, right? Okay then. Well, as what we've known about the process of processing the skin, then we collect it right after when they have released the skin from the processing plant, and because this is a byproduct, so they do not have the exact um, process for preservation as they will add some additives. But if they really do that, then it maybe will affect the total crude protein when we do the test, and therefore it will affect the composition of the raw material.
Okay, thank you. Question number 2. Did you measure the viscosity? Okay.
yeah, we didn't measure the viscosity of the protein hydrolysate actually. However, we suspect the viscosity is not pre, uh, not high because like the protein itself, when it existed in high concentration, it can cause the increase in the viscosity. However, when we cut it to the peptides, the high solubility of the solute will gradually reduce the viscosity. But however, we didn't measure that.
Okay, thank you. Question number 3. I think you do not need to answer. Now you should answer the question from the committee members. So Ms. Kiman, please, your question. The question are not so clear. Even me, I can't understand all of them. Ms. Kiman, please.
Yeah, I would like to ask the first question about the antioxidant activities. Yeah,
Yeah.
you measure antioxidant activities by DPPH and ABPS, right? And
Yes.
you found that you receive different antioxidant activity by two methods. Okay? So how about the difference between them? And
Um,
why? And why you have different optimum condition, okay, to receive
Yes.
the maximum antioxidants determined by two methods.
do we need to show the slide again? Miss Kiman.
No, I think just answer the question.
Okay, so for the two condition sets, then we have the same substrate to water ratio 1:2 for both, and for ES ratio we have 80 for DPPH and 60 for ABTS. For time we have 5 hour for DPPH and 6 hour for ABTS. So which means for DPPH we use more enzyme and we hydrolyze in fewer time than ABTS. And the difference here it could possibly because when we choose the assays to measure the antioxidant activity, and we basically based on many criteria, but one of them is because we choose the assays from two different mechanisms, the SET and the HAT mechanism. And for DPPH, it represents for the HET mechanism, and for the other. So the difference in the peak we receive, it will show that the same peptide it can have the antioxidant activity or the radical scavenging activity at different mechanism with different level.
May I add some information?
Yes.
One possible reason for that because the steric hindrance of the DPPH radical. Actually, the DPPH radical contain three aromatic rings, and which can somehow it have been proved to like inhibit the contact between the antioxidant and the radical itself. Therefore, for the better contact of the antioxidant, it must be smaller than that of an ABTS radical. And we need more enzyme to produce higher degree of hydrolysis to produce smaller peptides in order to act more efficient to the DPPH radical.
Okay, so that means your suggestion, yeah, your answer. Yeah, it's probably.
It has been proved for many. So I have read that on
The question here is, you have two conditions, two optimal conditions, okay? So that means you will have two hydrolysis, right? So the real thing here is they are really different in antioxidant activity, or it's just the measure by different methods.
So
You understand my opinion, my assumption here?
yes.
Yeah, it's really different in the antioxidant activity, or just by different measuring method used to determine the antioxidant activity. Because you will use two different technological conditions, okay?
Yes, sir. I understand. Yeah, it can be like it can both have both effects. Like as I mentioned before, due to the steric hindrance, the degree of hydrolysis needed for the two assays will be different, which will cause like a difference in the peptide length and maybe the amino acid the sequence of the peptide as well. And so it can affect the antioxidant of the peptide. And as when I mentioned before, the two assays also measure the two different like slightly different mechanism. So the two different condition can cause different in both like can cause different in the actual antioxidant activity.
Yeah,
Yeah,
and
and
I want to
I
add
want to
in
add
that
in that
when we
when we
decide to
decide to
choose
choose
one
one
condition set
condition set
for
for
the
the
optimum
optimum
hydrolysis,
hydrolysis, then
we have
we
made
have
a
made a
test
test
for
for
both
both
assays,
assays,
DPPH and
DPPH and
ABTS, to
ABTS,
find
to
out
find
if
out if
when
when
we
we
change
change
the
the
hydrolysis
hydrolysis
condition,
condition,
will it
will it
affect a
affect
lot
a lot
of
of
on
on
the
the
activity?
activity?
And now we
And now
see
we
that
see that
the
the
difference is
difference
not
is
very
not very
clear
clear
in
in
the
the
IC
IC
50
50
value,
value,
and
and
the
the
difference is
difference is
only
only
1.4%
1.4%
for
for
the
the
ABTS
ABTS
assay.
assay
For
for
testing the
testing the
uh, optimum
optimum
condition for
condition for
DPPH,
DPPH.
so we
So we
decide this
decide
is
this is a
suitable, this is
suitable, this is a uh,
appropriate
appropriate
result that we
result
can
that we can
receive.
receive.
Okay, so I have one more question. You you evaluate, okay, the effect of, I think, some temperature, I don't remember exactly, pH on functional properties of hydrolysis, right? You measure the emulsifying forming ability.
Yes.
Yes.
Now, in previous thesis of your friend, okay, for the couple binding capacity, okay, the result showed that pH temperature also affect the biological activity. So the question here is, do you think we will have one situation, X certain condition, okay? the biological activity may be very high, but the functional property may be very low. Okay? Do you think about that? Do you have similar result in any relationship between antioxidant activity of hydrolyzase and functional property at different pH and temperatures?
Yeah, we haven't done the research on the stability of the antioxidant activity according to pH, but according to what I've read, like the antioxidant can be affected by the pH, but since the pH can interfere with the mechanism, like different pH can cause different mechanism, and the the pH can affect the functional property, like by the conformant, like it's change the peptide structure. So the pH can affect both antioxidant activity and functional properties. How so there could be a point, a pH value that the antioxidant activity could be high and the functional property could be low, and it depends on the mechanism we're talking about. Sorry, can you repeat it?
Did you observe this? Okay, in your
No, I haven't observed observed it. Like I mentioned before, we haven't done the investigation on the pH, the effect of the pH on the antioxidant activity.
Yeah.
So there cannot be
so you cannot
a
compare.
specific solution.
You didn't see any relationship because you didn't do that experiment. Yeah. Okay.
Yes.
So you have to pay attention. Yeah.
Yes.
Can I add in something?
It's like I understand your question, but because the point of our research here is that we want to identify the bioactivity of the hydrolysate, and we choose the antioxidant. And also we have seen that when we supply the hydrolysate into other food system, into pharmaceuticals or functional properties, then the functional properties of the hydrolysate will affect the property of the whole system. So that's the reason why we carry out the experiment about the activity, the bioactivity, and functional properties also. So the meaning of the functional properties here can be considered as we use it as a texturizer, or maybe we just test it to know what will it affect when we apply it as a antioxidant source.
Yeah, I do understand. Yeah, I just have one suggestion to you that you have to pay attention also on the effect of pH and temperature on the biological activity of antioxidant activity as well. Yeah.
Yeah, we did plan to do it in the future, but
yeah. Thank you. I have no
Okay, thank you. Miss Ying, any questions?
Turn on
your microphone.
Sorry, I have no question.
Thank you, Miss Ying. Miss I, please.
Just listen on me.
I just have a small question. That is, which attribute that you choose when you want to optimize the process? For example, you choose antioxidants or you choose the functional properties?
Yep, we mainly focus on the antioxidant activity. The functional property is like a side effect that we can like research and announce the data for their use in future.
For the use in the future. Sorry, Winan, do you have answers? Okay. For the use in the future in the real industry, so how can we optimize the uses of the kind extraction or sample to the real product if we do not concern on the functional properties? Because it have very high quality have high antioxidant, but it do not have any functional properties. So how we can use it in the real industry? In which way we can apply it in the industry?
So as we mentioned in our conclusion, then we expect that our product can be supplement in the functional foods, pharmaceuticals, and we have found some food system that we can also apply this hydrolyzed as the fish sauce or the sausages. And because this is the protein source of additives, so the functional properties is one of the most important properties that it will show in the system. And meaning that when we try to explore about the functional property is that like besides of the side effects then somehow maybe because for example for antioxidant activity we have seen that we need to increase the concentration to get the same effect as a uh, traditional antioxidant that like we have known. So we can see that for that such high concentration, then the effect of the hydrolyzed in functional properties will be bigger.
Uh, yeah, due to my research, I found like the antioxidant peptide can be used like an antioxidative preservative. Like we can add it to some like products to improve the shelf life of that product. For example, like I found like salmon hydrolyzed can be added into some fillets that can extend the shelf life of the product. Or like when I said like supplements, like we can take it like as a pill, or even like further than food expect, we can apply it in cosmetic because it can prevent the oxidation caused by the UV light. That's what I have found.
Okay, thank you.
Okay, so my question. So I see the antioxidant activity you get from your hydrolyzed is quite low. If we compare it with the vitamin C, for example, it's 1,000 times lower than that of vitamin C. So what do you, how to say, have a comment, how do you have a comments about that? I don't think about the application is so far to the application because the result is so low. In some experiments, how to say, the gain in oxidative activity, if we compare with the value at the beginning of your hydrolysis, the gain is also so little too. So how do you comment about that, Gulam?
Like we have a lot of aspects to talk about this. The first thing is let's talk about the assays that we use to measure the activity. So we use DPPH and ABTS as first because we want to use two assays from two mechanisms. And then when we
I don't
add
talk about that. I say the value is a solar. Yeah.
yes, this
Although
is
you
the
try to
point.
test different assays, but they are quite low. So, what do you think? Is it potential to use such a material to get the antioxidant activity?
Okay,
Okay,
so
so my
my
point
point
is,
is,
I'm not sure it
is that
is
low,
that
but
low,
if
but if
it's
it's
really that
really that
low,
low,
then
then we
we
consider
consider
that
that
the
the
hydrolyzed
hydrolyzed
can
can
have
have
a lot of
other
other
bioactivities.
bioactivities.
And
And
of
of
course, to
course, to
compare with
compare with
vitamin C,
vitamin
then
C,
it's
then it's
significantly
significantly
lower. But
lower, but
vitamin C
vitamin
is
C is
only an
only an
antioxidant
antioxidant
component.
component.
But if
But
we
if we
can
can
prove that
prove that
our
our
hydrolyzed
hydrolyzed
have
have more than just only
antioxidant
antioxidant
activity,
activity,
such
such
as
as
it
it
can
can
chelate with
chelate
the
with the
metal,
metal,
or it
or it
can
can
antimicrobials,
antimicrobials,
antihypertensive,
antihypertensive,
then it will
then
be
it will be
the
the
additive
additive
with
with
various
various
activities
activities
to
to
apply in
apply
the
in
food
the food
system.
system.
So I think it's better when, how to say, you should focus on, how to say, another research, how to say, topic, yeah, based on your material. So I think there's no potential, yeah, to get an antioxidant preparation from a such material.
Can I add some information that I mentioned,
Yeah.
that I noticed? Yeah, as I shown you before, the content of phenylalanine is significant, more than 60%. The phenylalanine itself does not show the positive results in the DPPH and APTS scavenging assay, but it shown its antioxidant activity in the hydroxyl radical scavenging assay. So we suspect that in the future we need to test one more time with the hydroxyl radical scavenging assay to determine whether it should be used for application or not, since the hydroxyl radical is
Okay,
more.
but it's just a suggestion. It's just a suggestion because based on how to say the composition of the sample, you can suggest many things, but we're not sure about that. Yeah, a ring test is essential. Yeah, to validate, to verify if it's not correct. Now my question is, you try to determine the emulsifying properties as well as the forming capacity of your hydrolyzate, and I don't know why do you select sodium caseinate and albumin as a control sample. Why don't you select just one control sample for the both functional properties? Why do you try to distinguish sodium casein for emulsifying properties and albumin, but here we don't know what type of albumin for forming properties? Okay.
Yes, the reason that we try to separate them because like each of them stand for the best activity in one properties than the other. For
Are you
example, the
sure? Are you
casein,
sure sodium caseinate is the best for emulsifying properties?
like we want to choose like a protein based compare
Yeah,
with
but we have
another
different
protein base.
protein base. For example, we have whey protein. Whey protein is an excellent, how to say, protein with, how to say, excellent functional properties as well as emulsifying as well as forming capacity. What don't you select, for example, whey protein?
Uh, like we thought that like the casein itself is like popular, for example, in milk, and we want to
No,
compare, for
sodium
example, with.
caseinate is not popular in food industry.
Okay,
We use this
so
as a nutrient mostly, not as a functional agent.
yeah.
Can I add
Can I
in?
add in?
Sure.
In my point of view, that when we decide to choose the assays for measuring the functional properties, and we have read a lot of researches before and have really choose the control sample. And we have found that although we have a lot of kind of protein, but like for example, like whey protein is a mixture of a lot of kinds of protein soluble in the milk, but we choose sodium caseinate and albumin. They are the pure. Uh, they only have the one kind of protein, and we have
The hydrolyzed is also a mixture of different proteins. I'm sure about that. It's not really a pure, how to say, protein like albumin here or sodium caseinate.
Yes, but
yes, but
because we
because we
choose the
choose the
control
control
here for the
here for the
meaning of
meaning of
comparison with
comparison with
other
other
research
research
to show that
our
our
hydrolyzed is
hydrolysis is
higher
higher
lower
than
than
them.
them. Some
Some
point.
point. Therefore,
Therefore,
if we
we
choose
choose
the
the
substance like
substance like
sodium
sodium
caseinate and
caseinate and
albumin,
albumin.
it will
It
have
will
the
have the
higher
higher
chance that
chance that
for
for
other
other
research,
research,
if
if
they
they
also
also
choose
choose
that
that
substance,
substance,
that
that
it
it
will
will
not
not
affect
affect
a
a
lot
lot
to the
to the
result.
result.
But
But if
if
we
we
choose
choose
the
the
whey
whey protein,
protein,
then
then
the
the
whey
whey
protein
protein
we
we
choose
choose
compared
compared
to
to
the
the
other
other
whey
whey
protein,
protein,
there
there
will
will
be
be
a
a
significant
significant
difference,
difference,
which
which
leads
leads
to
to
the
the
different
different
results, and
results,
it
and
will
it
not
will
make
not
the
make the
meaning
meaning
of
of
measuring.
measuring.
Now, your product is a preparation. You should select a commercial preparation for comparison. That should be better, much better. Yeah?
Yeah, yeah.
Okay, thank you. I have no more questions. So we invite Ms. I to share the comments of the reviewers and the supervisors.
There are some comments in Vietnamese and there are some comments in English. For your supervisor, she comments that you have a well-structured thesis, and you have a nice presentation in your assignment or in your thesis. And for your defensor, she also give a good mention comments on the structure. Is very well structured and well organized, and you still have some like mistake on typing mistake. For example, like some page like 21, etc. But it's quite good. Thank you.
Okay, thank you, Miss I. Thank you for your presentation. So we invite the next student groups. So please